Jupiter does not need to touch another planet. It does not need to shine brighter, send signals, or announce its presence in any way we would recognize as action. Yet for billions of years, it has quietly helped keep the solar system moving in a stable, predictable rhythm. Far from the inner worlds, beyond the region where rocky planets circle close to the Sun, there is a massive presence that works in silence. Its influence is not sudden. It does not interrupt. It unfolds slowly, through gravity that spreads wide and deep, shaping motion rather than forcing it. Out here, order is not created through control, but through consistency. Orbits repeat. Paths settle into patterns. Movement becomes familiar, almost gentle, when viewed across immense spans of time. Jupiter exists in this calm role. Not as a center, not as a spotlight, but as a stabilizing weight at the edge of the system's inner balance. A reminder that some of the most important structures in nature are not designed to be noticed. There are systems that do not exist to be admired, but to be relied upon. There are forces that do not announce themselves, yet without them, everything begins to drift. In the quiet background of the solar system, Jupiter holds its place. And in that stillness, a long-lasting order is allowed to continue, steady and unhurried, as the universe slowly turns. When we speak about order in the universe, it is easy to imagine stillness, fixed positions, perfect balance, nothing drifting out of place. But in astronomy, order has never meant standing still. In fact, stillness is rare. Everything that matters is moving. Order in this context is not the absence of motion, but the presence of consistency within motion. The solar system is a dynamic system in constant activity. Planets circle the Sun. Moons circle planets. Even the Sun itself moves through the galaxy. These motions never stop, yet they remain remarkably predictable. That predictability is what astronomers call order, not quiet, not frozen, but reliable over time. This is an important distinction, because short-term stability can be misleading. A system may look calm over decades or even centuries, while slowly drifting toward instability on much longer timescales. Astronomy does not measure success in years or lifetimes. It measures it in millions and billions of years. An orbit that remains steady for 1,000 years tells us very little. An orbit that remains steady for billions of years tells us almost everything. This is why astronomers care deeply about long-term stability. They ask whether the paths of planets can endure slow gravitational nudges without unraveling. They look for systems that do not just survive brief moments of balance, but sustain that balance through immense stretches of time. Space rarely gives us simple answers. What appears stable today may not be stable forever. At the heart of this concern is the concept of orbital durability. An orbit is not a rigid track carved into space. It is a relationship constantly adjusted by gravity. Every planet feels the pull of every other planet, even if that pull is subtle. Over time, these small influences accumulate. A tiny shift repeated millions of times can reshape an entire system. Silence is also a kind of data. In astronomy, the absence of dramatic change often signals that a system is working as intended. When orbits remain orderly across deep time, it suggests that something within the system is quietly regulating motion. Not eliminating variation, but keeping it within limits. This is where the largest planets begin to matter. Massive worlds like Jupiter exert influence far beyond their immediate surroundings. They do not dominate through sudden force, but through steady gravitational presence. Their role is not to command, but to shape the environment in which smaller bodies move. Numbers whisper more than they speak. And the numbers associated with giant planets tell a story of long-term balance rather than short-term spectacle. From a human perspective, this kind of order can be difficult to appreciate. We experience time in fragments, days, years, generations. We rarely witness slow processes unfolding over millions of years. Yet astronomers build their understanding by extending human patience through mathematics, observation, and simulation. They imagine futures no one will see, and pasts no one remembers, searching for patterns that endure. In that sense, studying order in the solar system is also a quiet reflection on our own limits. We look for stability not because we expect perfection, but because we want to understand how complex systems avoid collapse, how motion can continue without chaos, how balance can exist without rigidity. As we begin to explore Jupiter's role in this vast structure, it helps to remember that order in space is not a static achievement, but an ongoing process maintained moment by forces that rarely draw attention to themselves. And perhaps the most remarkable thing about cosmic order is not how dramatic it looks, but how calmly it persists, even as everything continues to move. Jupiter does not sit close to the Sun, and it does not wander at the distant edge of the solar system either. Its orbit occupies a broad middle region, beyond the inner rocky planets and before the colder outer reaches. This distance is not accidental. It places Jupiter far enough away to avoid overwhelming the inner worlds, yet close enough to influence the structure of the system as a whole. In astronomy, where relationships matter more than appearances, position often carries more meaning than size. The rocky planets Mercury, Venus, Earth, and Mars circle the Sun in a compact arrangement. Their orbits are relatively tight, shaped primarily by the Sun's gravity and by their interactions with one another. Jupiter resides beyond this inner neighborhood, separated by space that allows its gravitational influence to spread gradually rather than intrusively. From this distance, Jupiter participates in the system without dominating it. Space rarely gives us simple answers, but here the balance is quietly precise. It is tempting to think that Jupiter's importance comes mainly from its immense mass. And mass does matter. But mass alone, without the right placement, would tell a very different story. A giant planet closer to the Sun would exert far stronger gravitational disturbances on the inner planets. Their orbits could become less predictable, more sensitive to small changes over time. Stability in such a case would be harder to sustain across billions of years. If Jupiter were much closer, its gravity would interact more intensely with the rocky planets. Small variations in orbital timing could accumulate faster. Long-term regularity would become more fragile. The solar system might still function, but its internal order would be more delicate, less forgiving. Silence is also a kind of data, and the absence of such disruption tells astronomers that Jupiter's current position is doing quiet work. On the other hand, if Jupiter were significantly farther away, its influence would weaken. It would still be massive, but its ability to shape the architecture of the system would diminish. Gravitational guidance works through proximity as much as strength. Too distant, and Jupiter's role in organizing motion would fade into the background. Numbers whisper more than they speak, and the numbers describing Jupiter's orbit reveal a location that is neither aggressive nor irrelevant. This middle placement allows Jupiter to act as what astronomers often describe as a gravitational anchor. Not an anchor that locks things in place, but one that provides reference and resistance to drift. Over long spans of time, Jupiter's steady presence helps define the boundaries within which other bodies move. Its gravity contributes to the overall rhythm of the system, shaping how orbits settle and remain coherent. From a human perspective, it can be helpful to imagine this in familiar terms. When engineers design large structures, they do not place their strongest supports arbitrarily. Position matters as much as strength. A support placed too close can create rigidity. Placed too far, it becomes ineffective. The same principle applies on a cosmic scale. Jupiter occupies a location that allows flexibility without chaos. Astronomers have explored alternative configurations through mathematical models, not to imagine dramatic outcomes, but to understand sensitivity. These studies show that even modest shifts in Jupiter's distance could lead to very different long-term behaviors. Not immediate disaster, but gradual divergence. Over hundreds of millions of years, such divergence matters. Order in astronomy is patient, and so are its failures. There is something quietly reassuring about this arrangement. Jupiter does not need to adjust its orbit or respond to events. It simply remains where it is, letting gravity do what gravity always does. The work is slow, repetitive, almost invisible. And yet that steady positioning contributes to a system that has remained recognizable for an immense span of time. As we consider Jupiter's place in the solar system, it becomes clear that its importance lies not only in what it is, but in where it is. In space, placement shapes influence, and influence shapes endurance. And sometimes, the most essential role is not to act, but to remain exactly where you are, allowing balance to emerge on its own, quietly and without urgency. When astronomers speak about Jupiter's mass, they are not simply describing how heavy the planet is. They are describing a fundamental property that shapes the behavior of the entire solar system. Jupiter contains the majority of the combined mass of all the planets. This single fact changes how everything else moves. It is not a dramatic statement. It is a structural one. Numbers whisper more than they speak. Mass in space is not just weight. It is influence. The more mass an object has, the more it shapes the gravitational landscape around it. Jupiter's mass creates a wide gravitational field that extends far beyond its visible form. This field does not end at the edge of the planet. It fades gradually, reaching into regions where smaller bodies travel, quietly altering their paths over long periods of time. It is important to understand that gravitational strength is not only about intensity, it is also about reach. A smaller planet can exert a strong pull nearby, but that pull drops off quickly with distance. Jupiter's gravity, by contrast, remains meaningful across a much larger volume of space. This difference between local gravity and large-scale gravitational influence is subtle, but it matters deeply for long-term order. Local gravity governs what happens close by. It shapes moons, rings, and immediate orbital neighborhoods. Large-scale gravitational influence works differently. It acts slowly, repeatedly, and over vast distances. Jupiter's mass allows it to participate in this second category. Its gravity does not need to dominate any single interaction. It only needs to persist, applying gentle guidance again and again as time unfolds. Silence is also a kind of data. The fact that many orbits remain stable over billions of years tells astronomers that Jupiter's influence is not disruptive. If its gravity were too strong in the wrong places, instability would accumulate. If it were too weak, structure would gradually loosen. The observed calm of the system suggests that Jupiter's mass is not excessive, but appropriately scaled to its position. Smaller planets cannot produce this effect even when they act together. Their combined mass is still modest compared to Jupiter. More importantly, their gravitational influence overlaps in complex ways that tend to cancel rather than reinforce large-scale order. A single massive body provides a clearer, more coherent gravitational presence. Numbers whisper more than they speak, and the numbers describing planetary mass reveal why scale matters. From a human perspective, it can be difficult to appreciate such slow influence. We are accustomed to forces that announce themselves immediately. Gravity on Earth feels constant, but its effects appear obvious and direct. In space, gravity works patiently. A slight tug, applied consistently over millions of years, can redirect entire populations of objects without ever appearing forceful in the moment. Astronomers learn to think this way because they must. They examine systems not as snapshots, but as long stories. Jupiter's mass becomes meaningful only when viewed through this long lens. It is not about sudden change, it is about cumulative guidance. Space rarely gives us simple answers, but here the lesson is quiet and clear. There is also humility in this understanding. Humans often look for singular causes and dramatic explanations. Jupiter's influence resists that instinct. Its mass does not act alone. It interacts with distance, timing, and the presence of other bodies. Order emerges not from one overwhelming factor, but from many conditions aligning gently over time. This is why astronomers speak carefully about mass. They do not treat it as a blunt instrument, but as a parameter in a delicate equation. Jupiter's mass is large enough to matter, but not so large as to destabilize. It participates without overpowering. It shapes without controlling. As we step back and consider this balance, it becomes clear that Jupiter's mass is not impressive because of its size alone. It is impressive because of how quietly it integrates into the system. A reminder that in the universe, enduring influence rarely announces itself loudly. Sometimes it is the steady presence of a single, massive body, patiently shaping motion across time, that allows order to continue without ever needing to draw attention to itself. When people imagine gravity at work in space, they often picture sudden pulls or dramatic shifts, as if planets are constantly being tugged from one direction to another. But Jupiter's gravity does not behave this way. It does not yank or jolt, it guides. Its influence is expressed not through abrupt motion, but through steady alignment over long periods of time. Jupiter's gravitational effect unfolds gradually. It acts continuously, shaping trajectories with small adjustments rather than decisive commands. Most of the time, these adjustments are too subtle to notice. An orbit today looks much like it did yesterday, and very much like it will tomorrow. The power of Jupiter's gravity lies not in intensity at any given moment, but in persistence across deep time. This is why its influence is often described as background rather than foreground. Like the low rhythm in a long piece of music, Jupiter's gravity provides a foundation that listeners may not consciously focus on, yet would immediately feel its absence. The rhythm does not compete with the melody. It supports it, keeps it grounded, and ensures that everything else has a reference point. In music, the background rhythm rarely changes quickly. Its purpose is not to surprise, but to stabilize. Jupiter plays a similar role within the solar system. Its gravitational presence creates a slow cadence that other bodies respond to, often without any dramatic interaction. Over millions of years, this cadence helps prevent small irregularities from accumulating into larger disruptions. Silence is also a kind of data. In astronomy, the lack of sudden orbital changes tells scientists that something is working quietly in the background. Jupiter's gravity contributes to this silence. By distributing its influence evenly across time, it avoids creating sharp disturbances. The result is not rigidity, but resilience. One of the reasons this slow influence is so effective is that gravity scales with repetition. A small influence applied once may seem insignificant. Applied millions of times, it becomes decisive. Jupiter's gravitational guidance does not need to force outcomes. It simply needs to be present again and again, as objects complete their orbits and return to familiar paths. From a human perspective, this can feel counterintuitive. We are conditioned to notice change when it is fast and visible. Slow processes often escape attention, even though they shape outcomes more reliably than sudden events. Astronomers learn to trust these slow processes because the universe consistently rewards patience. Space rarely gives us simple answers, but it often gives consistent ones. The distinction between fast and slow influence is critical to understanding cosmic order. Rapid forces tend to destabilize. Slow forces tend to regulate. Jupiter's gravity belongs firmly in the second category. It moderates motion by allowing systems to adjust gradually rather than react abruptly. This gradual adjustment is what allows stability to persist across enormous spans of time. Numbers whisper more than they speak. When scientists examine orbital data, they see patterns that emerge only when viewed over long intervals. The influence of Jupiter appears not as a spike or anomaly, but as a gentle bias in the overall motion of many objects. These biases accumulate quietly, shaping the system without ever calling attention to themselves. There is also a deeply human lesson embedded in this kind of influence. Not all guidance needs to be immediate. Not all structure comes from forceful intervention. Sometimes the most effective way to maintain order is to provide a steady reference, a background presence that allows everything else to find its own rhythm. As this chapter comes to a close, it is worth sitting with the idea that Jupiter's gravity does its work in near silence. It does not rush. It does not demand notice. It simply keeps time, moment after moment, orbit after orbit. And in that slow, dependable rhythm, the solar system finds a balance that feels less like control and more like quiet cooperation, unfolding without urgency as the universe continues its long, unhurried motion. The inner planets appear calm from our vantage point. Their paths around the sun seem steady, familiar, almost permanent. Yet this steadiness is not something they achieve on their own. It emerges from a network of gravitational relationships, many of which extend far beyond the inner region of the solar system. Among these relationships, Jupiter plays a quiet but persistent role. Jupiter does not interact directly with Earth or Mars in any dramatic way. There are no sudden pulls, no visible exchanges. Its influence is indirect, expressed through subtle adjustments that unfold over very long periods of time. These adjustments help shape how the inner planets respond to gravitational variations within the system. Space rarely gives us simple answers, and this influence is no exception. Mars, positioned at the outer edge of the rocky planet region, is particularly sensitive to long-term gravitational patterns. Its orbit carries traces of interactions with Jupiter that are too gradual to notice in a single lifetime. Over millions of years, Jupiter's steady presence helps prevent Mars from drifting into configurations that would amplify instability. The result is not a fixed path, but a restrained one, guided rather than forced. Earth, too, benefits from this restraint, even though the connection is less obvious. Jupiter's gravity contributes to the overall architecture that limits how much Earth's orbit can wander. This does not mean Earth's path is perfectly constant. Small variations occur, and they always have. What matters is that these variations remain within a range that allows long-term continuity. Silence is also a kind of data, and the lack of extreme orbital shifts over geological time speaks quietly but clearly. It is important to emphasize that stability in astronomy is never absolute. Orbits evolve. They breathe slightly, expanding and contracting in response to complex gravitational interactions. Jupiter does not eliminate this motion. Instead, it reduces the likelihood that small changes will cascade into large, chaotic ones. Numbers whisper more than they speak, and the numbers describing orbital behavior suggest moderation rather than control. This moderation is what allows conditions to persist over billions of years. A system that is too rigid cannot adapt. A system that is too loose cannot endure. Jupiter's influence helps keep the inner planets within a middle ground, where gradual change is possible without sudden disruption. This balance is not accidental. It arises from the combined effects of mass, distance, and time working together. From a human perspective, it is tempting to look for simple guardians or protectors in cosmic stories, but Jupiter's role resists that framing. It does not act as a shield in any active sense. Instead, it shapes the environment in which orbits evolve. Its contribution is structural rather than reactive. Space rarely gives us simple answers, but it often rewards careful framing. Astronomers study these effects through models that stretch far beyond human timescales. They simulate millions of years, watching how small influences accumulate. In these simulations, Jupiter's presence consistently reduces the frequency of extreme outcomes, not by preventing change, but by slowing it. This slowing is often the difference between endurance and instability. There is something quietly human in this process. In our own systems, whether ecological, social, or personal, long-term stability often depends on influences that are steady rather than forceful. Jupiter offers a cosmic parallel. Its gravity does not announce itself, but it remains, shaping outcomes through patience rather than intensity. As this chapter draws to a close, it becomes clear that the inner planets do not owe their stability to isolation. They are part of a larger gravitational conversation, one in which Jupiter speaks softly but continuously. And in that ongoing exchange, order is not imposed but maintained, allowing the solar system to evolve without losing its coherence, slowly and calmly, across the deep and unhurried flow of time. Orbital resonance is one of those ideas in astronomy that can sound complicated at first, yet feels intuitive once it is allowed to settle. At its heart, resonance is simply about timing. When two bodies move in rhythms that repeat in a regular pattern, their gravitational interactions begin to align. Nothing sudden happens. No forceful adjustment is made. Instead, small influences arrive again and again at familiar moments. A helpful way to picture this is through everyday motion. Imagine walking across a room while someone gently taps the floor at the same point each time you step. The tap is not strong and it does not push you in any direction. But over time, its consistency begins to shape how you move. Orbital resonance works in a similar way. Gravity arrives at predictable intervals, and repetition gives those gentle nudges meaning. Because of this, resonance is often misunderstood as something inherently destructive. In some cases, repeated gravitational timing can increase motion and lead to instability. But this is only one possibility. Just as repetition can amplify, it can also organize. In many regions of the solar system, resonance leads to structure rather than chaos. Space rarely gives us simple answers, and resonance is a clear example of that balance. Jupiter's role in resonance is subtle. Its mass provides a strong gravitational rhythm, but it does not impose outcomes. Instead, it participates in a long conversation of timing. Objects that fall into stable, resonant patterns tend to settle into predictable paths. Those that do not may gradually drift away. Over time, this process creates order not by force but by preference. Some arrangements persist because they are naturally reinforced. Silence is also a kind of data. The existence of long-lasting resonant patterns tells astronomers that these relationships are not inherently unstable. If resonance were always destructive, such patterns would not survive for billions of years. Their persistence suggests that repetition, when balanced, can support stability rather than undermine it. This is why it is more accurate to say that Jupiter helps arrange rather than command. It does not dictate where other bodies must go. It simply provides a consistent gravitational backdrop. Through repeated interactions, certain pathways become more likely than others. Over time, the system organizes itself around these tendencies. Numbers whisper more than they speak, and the numerical ratios behind resonance reveal a quiet logic rather than a dramatic rule. From a human perspective, this kind of organization can feel unfamiliar. We often associate order with direct control. We expect instructions, boundaries, enforcement. In nature, and especially in space, order often emerges from repetition without oversight. The system does not need to be told what to do. It learns in a sense through experience, adjusting gradually as interactions repeat. Astronomers observe this process not as a single event, but as an accumulation. They model thousands of orbits, then millions, watching how resonant patterns either stabilize or fade. Jupiter's influence appears not as a decisive push, but as a steady rhythm that allows certain configurations to endure. Space rarely gives us simple answers, but it does reveal consistent ones to those willing to look slowly. There is also a quiet lesson here for how we understand stability more broadly. Repetition does not always lead to monotony. It can lead to refinement. Each cycle reinforces what works and gently discourages what does not. Jupiter's gravitational rhythm participates in this refinement process on a cosmic scale. As this chapter comes to an end, it becomes clear that orbital resonance is less about control and more about cooperation. Jupiter does not force order upon the solar system. It offers a rhythm, and through countless repetitions, that rhythm allows natural arrangements to take shape. Order emerges not because something demands it, but because repeated interactions make it the most enduring path, unfolding calmly as time continues forward. Beyond the familiar paths of the planets, the solar system is filled with smaller travelers. Asteroids, comets, and ancient fragments move quietly through space, carrying records of the system's earliest history. These bodies are not remnants to be ignored. They are part of the same gravitational story, shaped by the same forces, responding over time to influences that are patient rather than dramatic. Asteroids tend to occupy regions where motion has settled into long-standing patterns. Comets arrive from farther out, often following elongated paths shaped by distant gravitational interactions. Together, these objects form a kind of background population, moving continuously, rarely noticed, yet essential to understanding how the solar system organizes itself. Silence is also a kind of data, and the persistence of these populations tells astronomers that the system has rules that favor endurance. Jupiter plays a central role in shaping the motion of these small bodies, but not in the way it is often imagined. It does not act as a shield that intercepts objects or actively protects the inner planets. That framing suggests intention and reaction, neither of which apply in celestial mechanics. Jupiter's influence is quieter and more neutral. It redistributes momentum. When a small body passes through Jupiter's broad gravitational field, its path can be altered. Sometimes the change is subtle, sometimes more noticeable, but it is always governed by the same physical principles. Energy and momentum are exchanged according to predictable laws. Jupiter does not decide outcomes, it participates in them. Numbers whisper more than they speak, and the equations describing these interactions reveal balance rather than judgment. This redistribution of momentum helps explain why certain regions of the solar system maintain structure over long periods of time. The area between the inner rocky planets and the outer giants is not empty, but it is not chaotic either. Jupiter's gravity contributes to maintaining that structure by influencing how small bodies circulate within it. Objects are guided into stable patterns or gently redirected elsewhere. Over time, this creates a form of order that emerges naturally. Astronomers see this clearly when they study populations of asteroids. Their distribution is not random. Gaps and clusters appear where gravitational influences have acted repeatedly. Jupiter's presence is woven into these patterns, not as a controlling force, but as a shaping one. Space rarely gives us simple answers, but here it offers a quiet lesson in how structure can arise from repeated interaction rather than intervention. Comets tell a similar story. Their long journeys through the solar system are influenced by encounters that may occur only once in many thousands of years. Yet even these rare encounters matter. A small change in trajectory, applied patiently over time, can determine whether a comet remains a distant visitor or becomes part of a more regular pattern of motion. Jupiter's gravity contributes to these outcomes by gently altering the flow of objects through the system. From a human perspective, it can be helpful to think of this process as circulation rather than defense. In natural systems on Earth, stability often depends on the movement and redistribution of energy rather than its containment. Rivers shape landscapes not by stopping water, but by guiding its flow. Jupiter performs a similar role on a cosmic scale, allowing motion to continue while preventing disorder from accumulating unchecked. This perspective also explains why smaller planets cannot replicate Jupiter's influence. Their gravitational reach is limited. They can affect nearby objects, but they lack the scale needed to shape entire regions. Jupiter's mass and position allow it to interact with many small bodies across a wide range of distances, contributing to the overall coherence of the system. Astronomers reconstruct these processes by looking backward as much as forward. They study how present-day distributions likely emerged from earlier conditions. The consistent patterns they observe suggest that Jupiter's influence has been steady over immense spans of time. Silence is also a kind of data, and the absence of widespread disruption supports this view. As this chapter comes to a close, it becomes clear that Jupiter's relationship with the small bodies of the solar system is not about protection or threat. It is about flow. Through slow, repeated interactions, momentum is shared, paths are adjusted, and structure is maintained. And in that quiet circulation, the solar system preserves a balance that does not demand attention, but rewards patience, continuing its long, measured motion through space without urgency or display. The solar system is often described as stable, but stability in astronomy does not mean stillness or perfection. Change continues to occur. Orbits shift slightly. Small bodies collide. Over long spans of time, the system evolves. This does not contradict the idea of order. It defines it. Order in space allows movement, adjustment, and gradual transformation without losing coherence. Jupiter does not prevent every collision or eliminate all sources of irregularity. Its gravity is not a barrier that stops motion. Instead, it slows the pace at which disorder can grow. By reducing the speed and scale of change, Jupiter helps ensure that variation remains manageable over immense periods of time. Space rarely gives us simple answers, and the persistence of change within order is one of them. This distinction matters because absolute stability would be fragile. A system with no flexibility cannot absorb disturbance. Small irregularities would have nowhere to go, and pressure would accumulate. The solar system avoids this fate by remaining dynamic. Orbits adjust slightly. Energy is redistributed. Over time, these small changes allow the system to respond rather than resist. Silence is also a kind of data. The fact that the solar system has not unraveled despite billions of years of motion suggests that its structure is resilient rather than rigid. Jupiter contributes to this resilience by moderating interactions, not suppressing them. It creates conditions where change is slow enough to be integrated into the broader pattern. From a scientific perspective, this is described as dynamic stability. The system remains recognizable even as it evolves. Jupiter's influence helps keep variations within a range that does not lead to runaway effects. Numbers whisper more than they speak, and the long-term behavior of orbits reveals consistency beneath gradual transformation. Small instabilities play a role in this process. Minor shifts in orbital paths, slight changes in energy distribution, and occasional collisions contribute to long-term evolution. These events are not flaws. They are part of how the system explores its own limits without crossing them. Jupiter's presence ensures that this exploration happens slowly, giving the system time to adjust. Human experience offers a useful parallel. In many complex systems, from ecosystems to social structures, complete rigidity leads to collapse. Adaptation requires movement. The same principle applies on a cosmic scale. Jupiter does not enforce order by freezing the system in place. It supports a framework where change can occur without becoming destructive. Astronomers observe this balance through simulations that span millions of years. They watch how small irregularities either fade or grow depending on the surrounding conditions. Jupiter's steady gravity often shifts these outcomes toward moderation, not by eliminating variation, but by shaping its tempo. Space rarely gives us simple answers, but it consistently reveals the value of patience. This understanding also tempers how we think about chaos. Chaos in astronomy is not synonymous with destruction. It describes sensitivity to initial conditions, not inevitable collapse. Jupiter reduces that sensitivity by smoothing extremes over time. The result is not a perfect system, but a durable one. As this chapter comes to a close, it becomes clear that the strength of the solar system lies in its ability to change without losing itself. Jupiter's role in this process is subtle and continuous, allowing motion, evolution, and occasional disruption to occur within a stable framework. And in that balance between change and continuity, the solar system finds a form of order that endures not because it is flawless, but because it is flexible, unfolding calmly as time moves forward without urgency or finality. Considering a solar system without Jupiter is not an exercise in imagination for its own sake. Astronomers approach this question through careful modeling, not speculation. By adjusting equations and removing one variable at a time, they explore how systems behave under different conditions. This method does not ask what would happen suddenly, but how patterns might shift over immense stretches of time. When Jupiter is removed from these models, the change is not immediate. Planets do not scatter. Orbits do not collapse. For long periods, the system can appear familiar. This is an important point. The absence of Jupiter does not lead to instant disorder. Space rarely gives us simple answers, and gradual change is often the most telling. Over longer timescales, however, differences begin to emerge. Without Jupiter's steady gravitational presence, the inner planets experience fewer constraints on their motion. Small variations that would otherwise be moderated can persist and accumulate. Orbits become more sensitive to minor disturbances. The system remains functional, but its margin for stability narrows. Mars, in particular, shows greater variability in these models. Its orbit, already more flexible than Earth's, responds more strongly to long-term gravitational shifts. Over millions of years, this increased sensitivity can lead to wider swings in orbital shape and orientation. Earth, too, is affected, though more subtly. Changes unfold slowly, almost invisibly. but they are measurable in extended simulations. Numbers whisper more than they speak. The data does not point to catastrophe, but to increased irregularity. The system drifts toward configurations that are less predictable and more varied. This does not mean instability becomes inevitable. It means stability becomes less robust. The difference is quiet but meaningful. Silence is also a kind of data. The fact that such changes take so long to appear underscores how deeply time is woven into astronomical processes. Jupiter's influence operates on scales that resist quick observation. Removing it reveals how much of the system's calm depends on long-term moderation rather than short-term control. It is important not to frame this comparison in extreme terms. A solar system without Jupiter would still be governed by gravity, the Sun would remain dominant, the inner planets would continue their paths. What changes is the texture of motion. Without Jupiter, the system becomes more responsive to small influences, more open to gradual divergence. Astronomers study these differences not to suggest that Jupiter is essential in an absolute sense, but to understand how large bodies contribute to resilience. The presence of Jupiter increases the range of conditions under which the system can remain orderly. Its absence narrows that range. Space rarely gives us simple answers, but it often reveals contrasts that deepen understanding. From a human perspective, this kind of comparison is a reminder of how stability often depends on unseen factors. We notice when systems fail, but rarely when they quietly hold together. Jupiter's role becomes clearer when it is removed from the equation, not because chaos erupts, but because subtle order fades. As this chapter comes to a close, the lesson is not that the solar system would fall apart without Jupiter. It is that the system would behave differently, evolving with less restraint and more variability over deep time. And in that difference, we glimpse how the presence of a single, distant giant contributes to a balance that feels calm not because it is guaranteed, but because it is patiently supported moment after moment across the long and unhurried flow of cosmic time. When scientists describe Jupiter's role in the solar system, they often reach for comparisons drawn from nature on Earth. Not because the systems are the same, but because the underlying principles are familiar. In many natural environments, stability is maintained not by blocking change, but by regulating it. Rivers distribute energy through flow. Forests balance growth through cycles of renewal. Climate systems adjust through feedback rather than absolute control. Space rarely gives us simple answers, but these parallels help clarify what Jupiter is quietly doing. On Earth, systems that attempt to stop movement entirely tend to fail. A river that is dammed without release builds pressure. An ecosystem that is frozen in place loses resilience. Nature favors regulation over prevention because regulation allows adaptation. Jupiter follows this same pattern on a cosmic scale. It does not halt motion within the solar system. It shapes how that motion unfolds. This distinction is important. Jupiter is often described as blocking or intercepting influences, but that language can be misleading. Blocking implies resistance and force. Regulation implies guidance and balance. Jupiter's gravity does not act as a wall. It acts as a field through which motion passes, changing direction, timing, and distribution without stopping it outright. Silence is also a kind of data. The long-term persistence of planetary orbits suggests that regulation, not obstruction, is the dominant mechanism at work. If Jupiter's role were purely to block, the system would become rigid. Instead, it remains flexible. Orbits shift slightly. Energy moves through the system. Stability emerges from continuous adjustment rather than fixed boundaries. On Earth, temperature regulation offers a clear example. The climate does not maintain a single temperature. It oscillates within ranges that support long-term continuity. Feedback loops moderate extremes without eliminating variation. Jupiter functions in a similar way. Its gravitational influence dampens extremes over time, allowing the solar system to explore change without drifting into instability. Numbers whisper more than they speak. When astronomers examine long-term simulations, they do not see Jupiter enforcing order through sharp interventions. They see smoother transitions, slower divergence, and fewer extreme outcomes. These are the signatures of regulation. They suggest a system that absorbs variation rather than rejecting it. From a human perspective, regulation can feel less reassuring than control. We often prefer barriers and rules that promise certainty. But natural systems rarely operate this way. They depend on balance, feedback, and patience. Jupiter's influence reflects this natural preference. It participates in the solar system's motion without attempting to dominate it. This perspective also helps explain why Jupiter's role cannot be easily replaced. Regulation depends on scale, placement, and persistence. Smaller planets lack the reach. Larger forces placed differently would disrupt rather than regulate. Jupiter's effectiveness arises from how well its properties align with the system's needs. Space rarely gives us simple answers, but alignment is often more important than strength. Astronomers view Jupiter as part of a broader self-balancing mechanism. The solar system does not rely on a single component acting alone. It emerges from the interaction of many influences. Jupiter contributes by smoothing the system's response to internal variation. It allows motion to continue while preventing rapid escalation. There is a quiet human resonance here. In many areas of life, long-term stability depends less on stopping problems and more on managing them gently over time. Systems that endure are those that adjust continuously. Jupiter offers a reminder that balance does not require force, it requires presence. As this chapter comes to a close, it becomes clear that Jupiter's most important function is not dramatic or visible, it is regulatory. Like many natural systems on Earth, it maintains stability by allowing movement within limits, and in doing so, it becomes part of a self-correcting structure that does not resist change, but guides it patiently, letting order emerge again and again, calmly, as the solar system continues its slow and steady passage through time. From where we stand, Jupiter feels distant and abstract. We do not sense its gravity. We do not feel its pull in our daily lives. Nothing in our immediate experience tells us that a massive planet, hundreds of millions of miles away, is quietly shaping the long-term order of the solar system. This absence of sensation is not a failure of perception. It is a reminder of scale. Human intuition evolved to navigate short distances and short times. We are skilled at noticing quick changes and immediate causes. Slow influence, especially when spread across enormous distances, escapes direct awareness. Jupiter's role belongs entirely to this invisible category. Silence is also a kind of data, and the lack of direct sensation tells us something important about how cosmic systems operate. The recognition of Jupiter's influence did not come all at once. It emerged gradually, through centuries of observation, calculation, and refinement. Early astronomers tracked motions, compared predictions, and noticed small discrepancies. Over time, patterns began to appear. Orbits behaved as if influenced by something more than the Sun alone. These insights required patience rather than revelation. Astronomy advances by accumulation. Each observation adds a small piece to a larger picture. Jupiter's role became clearer as models improved and time horizons expanded. What once looked like minor irregularities revealed deeper structure when viewed over longer spans. Space rarely gives us simple answers, and understanding Jupiter required a willingness to wait. Even today, our intuition struggles with these ideas. We tend to imagine influence as something that announces itself, a push, a signal, a visible effect. Jupiter offers none of these. Its gravity works continuously, quietly, and without interruption. Numbers whisper more than they speak. And only by listening to those whispers do astronomers learn what is happening. This gap between intuition and reality shapes how science is practiced. Astronomers rely on mathematics and long-term observation precisely because direct perception is insufficient. They simulate futures no human will witness and reconstruct pasts no one recorded. Jupiter's influence becomes meaningful only when human time is extended through calculation. There is also humility in this process. The more we learn about large systems, the more we recognize the limits of instinct. Our first impressions are often incomplete. What feels insignificant may be structurally essential. Jupiter teaches this lesson gently. Its importance is revealed not through spectacle, but through consistency. Patience then becomes a scientific tool. Discovering Jupiter's role required waiting through generations of data, refining theories, and resisting the urge for quick conclusions. Silence is also a kind of data, and the quiet regularity of planetary motion speaks volumes when observed long enough. This patience is not passive. It is active attention stretched across time. Astronomers learn to trust slow evidence, to value patterns that emerge only after repeated observation. Jupiter rewards this approach. Its influence becomes clearer the longer one looks, not the harder one looks. From a human point of view, there is something calming in this realization. Not everything important announces itself. Some of the most powerful influences in the universe operate beneath awareness, shaping outcomes without ever demanding notice. Jupiter stands as an example of that quiet power. As this chapter comes to a close, it becomes clear that observing Jupiter is as much about understanding ourselves as it is about understanding space. We learn that patience expands perception, that intuition must be supplemented by time, and that in a universe governed by slow, persistent forces, true understanding arrives not suddenly but gradually, unfolding calmly as attention is sustained across the long and measured passage of years. In the universe, order does not announce itself. It does not arrive with sharp signals or sudden changes. More often, it reveals itself through continuity, through patterns that repeat without drawing attention, through motions that feel so familiar they almost disappear into the background. Order in this sense is not loud, it is dependable. Astronomy teaches this lesson slowly. When scientists study the solar system, they do not look for moments of drama, they look for what persists. They examine what remains steady across immense spans of time. Space rarely gives us simple answers, but it consistently shows that endurance matters more than spectacle. Jupiter embodies this kind of quiet order. Its presence is unmistakable when measured, yet barely noticeable when experienced. It does not dominate the sky from Earth. It does not alter our daily lives in any way we can feel. And yet, across billions of years, its steady gravity has helped shape the environment in which all the planets move. This is a form of strength that does not seek attention. Jupiter does not act through intervention or command. It simply exists where it is, doing what gravity always does, patiently and without urgency. Numbers whisper more than they speak, and the long-term behavior of the solar system reflects those whispers more than any single event ever could. In human terms, this challenges how we often think about importance. We are drawn to what is visible and immediate. We notice what interrupts our attention. But many of the systems we depend on most operate quietly, Our bodies regulate themselves without conscious input. Ecosystems balance through countless small interactions. Stability often comes from processes that remain unnoticed until they fail. Silence is also a kind of data. The calm continuity of planetary motion tells us that something is working, even when nothing appears to be happening. Jupiter's influence belongs to this category. Its success is measured not by action, but by the absence of disruption. That absence is meaningful. There is a gentle connection here between science and human experience. In both realms, the most lasting forms of order are rarely imposed. They emerge from relationships, repetition, and patience. Jupiter does not enforce balance, it participates in it. Over time, that participation becomes structure. Astronomers learn to appreciate this through long observation. They study systems not for what changes quickly, but for what holds together. Jupiter becomes important not because it does something dramatic, but because it helps prevent small variations from becoming overwhelming. Space rarely gives us simple answers, but it often rewards attention to the quiet ones. This perspective can feel comforting. It suggests that stability does not require constant effort or control. Sometimes, it arises from simply being present in the right way, over the right amount of time. Jupiter offers a cosmic example of that principle. Its strength lies in persistence, not performance. As we step back from the details of gravity, resonance, and orbital motion, what remains is a broader understanding of how order exists in the universe. It is not rigid. It is not fragile. It is adaptive, patient, and often invisible. Jupiter's role reminds us that influence does not need to be forceful to be real. As this chapter comes to a close, we are left with a quiet image. A massive planet, distant and silent, continue in its orbit without urgency. Around it, a system unfolds that has remained recognizable for billions of years. And within that stillness, a lesson lingers. That the most enduring forms of order are often the least noticeable, unfolding calmly without demand, as time continues on its slow and steady path through the vastness of space. Jupiter does not appear in our daily routines. We do not see it when we wake. We do not feel its presence as we move through ordinary moments. And yet, it remains an essential part of the structure we live within. Its role does not depend on attention or awareness. It depends on position, persistence, and time. The order of the solar system is not built from dramatic motion. It is shaped by repetition, by orbits that return again and again to familiar paths, by relationships that remain steady because they unfold slowly. Jupiter contributes to this order not by acting, but by remaining. Space rarely gives us simple answers, but it often reveals that endurance matters more than display. Jupiter stands as a reminder that not all strength is loud. Some forms of influence never announce themselves. They operate beneath sensation, shaping outcomes without interrupting experience. Numbers whisper more than they speak, and the quiet stability of planetary motion reflects those whispers across billions of years. From a human perspective, this can feel reassuring. Much of what supports our world works in the same way. Systems we rely on function continuously without asking to be noticed. Stability often comes not from constant effort, but from consistent presence. Jupiter mirrors this truth on a cosmic scale. As we let these ideas settle, it becomes easier to release the need for explanation. The universe does not require our attention to continue. It moves forward steady and unhurried, whether we observe it or not. Silence is also a kind of data, and the calm continuity of the solar system tells its own story. As this journey comes to a close, there is nothing left to resolve. Jupiter continues its orbit. The planets keep their paths, And somewhere within that quiet motion, order persists. You can allow your thoughts to drift, knowing that even as you close your eyes, the universe remains in balance, carrying on its slow and patient rhythm without urgency, without demand, simply continuing as it always has.